So in this video we will understand the naming of ionic compound, and so before understanding the naming of ionic compound we should understand about the ions. What are the ions? And we will also see about the how to write the ionic compound and how to name them. So writing and naming, both we will see in this video. So first we have to understand what are the ions. When an atom of a group of atoms loses or gain electron, it become an ion. For an example, these are the metal and here are some non-metals or with the charges. You can see some hydrogen is plus, lithium is plus, sodium plus, potassium plus, rubidium plus, calcium plus, cesium plus, magnesium 2 plus, calcium 2 plus, strontium 2 plus, barium 2 plus, aluminum 3 plus, nitrogen 3 minus, oxygen minus 2, hydrogen minus, this is called hydride actually, fluoride minus 1, chloride minus 1. So there is no 1, but if there is no number it means there is 1. So bromide ion. So these are the ions. So usually metal have a tendency to lose the electron. Once they lose the electron, and electron have a negative charge, so when they lose the electron, the remaining ion get a positive charge. So if hydrogen have 1 electron and 1 proton, when it loses 1 electron, it get 1 positive charge plus 1 electron it loses, right? Similarly, if calcium and barium in this group, mostly the metal loses 2 electrons, that is why they are getting 2 plus. However, in case of this is aluminum 3 plus, and then in case of non-metals have a tendency to gain the electrons. So for an example, fluorine is an atom, there is no charge, but when it get electron it get fluoride ion, right? So when any atom gets an electron it get charge. So when an atom of a group, when an atom or a group of atom, basically it should be or a group of atoms loses or gain electrons, it become an ions, cations. So now there are two types of ions, number one cations and second is anions. Cations are formed when at least 1 electron is lost. Monoatomic cation are formed by metals. So these positively charged ions are called cations. You can also remember these cations. You can see there is a cations have a cat, CAT, cat. Cats are mostly you can think as a positive nature. So that is why you can also say that cations are positively charged. And then anions are formed when at least 1 electron is gained, and monoatomic anions are formed by non-metals except the noble gases. Noble gases are at the end, so they don't make any charges, they are very stable. So anions are negatively charged and cations are positively charged. So this was about the charge of ions and what are the ions. Let's see some more about the common charges in the periodic table. So this is a rough idea about the periodic table. So periodic table have a column and rows. So first column, which is called first A, have a positive charge. All the element which are in first column, they have +1 charge. Whenever they make an ions or cations, they are monoatomic cations. These are the dications, probably basically 2 charges. And then in the center, more commonly we will encounter like iron, copper, zinc, chromium, manganese, cobalt. So they have various different charges. They can be in the plus, 2 plus, or 3 plus, 1 plus, or 2 plus. Copper can be exist in 1 plus and 2 plus. Zinc can be 2 plus. Chromium exists in 3 different charges of cations. So similarly, on the non-metal side, column number 3A, 4A, 5A. So 3A have mostly 3 plus charge. 4A have 4 plus and 4 minus. It can be any. 5A have mostly minus 3. 6A have minus 2. And 7th A has, which is called halogens, they have minus 1. So this is the general trend about the charges in the periodic table, and this will be very helpful when we will name them, or we will find out how many charges will have any atom or ions. So writing of the formula, before understanding the naming, we have to figure it out how to write the ionic formula. So for an example, magnesium ion and nitride ion, when they mix together, they make a trimagnesium dinitride. And how we write the formula? It's very simple. First you have to find out how many charges of element or ions cation have, and this is an anion which have a 3 plus charge. So you have to just use these number of charges as a subscript. So this 2 will go at the end of the nitrogen, and this 3 will go at after the magnesium. So how we will write the formula of this one? Mg3N2. This is the easiest way to write the ionic formula, and then in this way you can balance their charges also, because if you are taking 3 magnesium and each magnesium has 2 plus charge multiplied by 3, which will be equal to plus 6 plus. So if you are taking 3 magnesium, it means you have total 6 plus. To balance 6 plus, you need 2 nitrogen. Means nitrogen have 3 minus, and when you will multiply or when you will add one more 3 minus, so this will become 6 minus. So now you can see by writing their charges value as a subscript, we are balancing their charges also, and we are neutralizing their charges. So plus 6 will be balanced by minus 6, like this. So because compounds are electrically neutral, yeah, this is why we did, because we have to make them neutral. One can determine the formula of compound this way. The charge on the cations become a subscript of anion, and the charge of anion become a subscript of cation. If these subscripts are not in the lowest whole number ratio, divide them by greatest common factor. Divide them. So that is why we move this charge, positive charge, at the end of this nitrogen as a subscript, and nitrogen charges, so anion charges are at the end of the cations, and cation charges will be at the end of nitrogen anions. So this is the way we write the ionic formula. So let's see some more examples. Writing ionic formula, the chemical formula for an ionic compound is always written as an empirical formula. So empirical formula we have understand in my previous video. So whenever we write any chemical formula of ionic compound, we always write as an empirical formula. So sodium chloride, sodium has one positive and one negative, so we have to move one is here, one is here. So since we don't write any 1, so we can write as such, sodium chloride. Iron 3 plus and bromide -1. So we have to move 3 at the bromine place and 1 at the iron place. So iron will be 1 and bromine will be 3. So iron 3 bromide, like tribromide. And then magnesium nitride, we have seen this example in previous slide. So let's see some more examples in continuation of this one. So if we have any charge on the cation like A plus and on anion like B minus, then we have to cross over to each other and to make a subscript. So this will be like a formula for writing ionic formula. Ionic formula, small m, capital M, small b as a subscript, and capital X, small a will be. So here these are the same example. This is the unique one, last one. Aluminum 3 plus and sodium and then sulfate is a -2. So this sulfate is a polyatomic. We will see what is the polyatomic. Poly means many. So there are 2 atoms are together, and this is a group of atom which have a charge. So what we do, we write a 3 at the end of the sulfate, but we have to move this in the parenthesis, and then we will use this 2 minus anion charge will make as a subscript of aluminum. So this will become aluminum 2, and then sulfate 2 you have to make in the parenthesis, and you need not to write any charge because you are writing 3 from the cation charge as a subscript. So this will be dialuminum trisulfate. So this way we manage the polyatomic ions. Now we have to understand the naming of these ionic compound. So how we will name them? So first you have to find out, is the metal in the compound of known charge, that is the metal from the group 1 or group 2, or is it aluminum, zinc or silver? So aluminum, zinc and silver, they have specific charges. Aluminum 3 plus, zinc 2 plus and silver 1 plus. And group 1 have 1 plus 1 charge, and group 2 has plus 2 charge. This we have seen in this slide. You can see the group 1 and this is group 2. So group 1 has plus 1 charge, group 2 has 2 plus charge, and zinc has 2 plus, and aluminum and silver. So aluminum has 3 plus and then silver have 1 plus charge. So we will, if yes, so if the metal of a compound of known charge, if we know the charge of metal, then the name of the metal and then the non-metal. Use "ide" at the end if the compound is a binary, and use appropriate ending if the compound has polyatomic anion. For an example, calcium chloride. So this is calcium, we know that has 2 plus charge and chloride is -1. So calcium chloride, we are using "ide" as a suffix at for the second one. And then here is an example of diatomic or polyatomic ion, which is sodium. We know sodium is from group number 1, which is positive 1 charge, and then hydrogen and then oxygen. This is hydroxide ion, and hydroxide ion has -1 charge. This is a polyatomic ion, and anion we will say. So we have to move, we have to write 2 subscript here because we have to balance sodium hydroxide. No, this is not correct. Yeah, this is not correct. So basically here we have to write only sodium hydroxide, NaOH. This should not be in any parenthesis. No, this is not correct. So in this slide we have to make this correction. So sodium hydroxide, because sodium has +1 charge and hydroxide has a -1 charge, so we have to write as such. So sodium hydroxide, name is correct, this parenthesis and 2 is not correct. So let's see the next rule in the naming of ionic compound. Naming of ionic compound in continuation is the metal in the compound of known charge is that a metal from the group 1 or group 2 or is in aluminum, zinc and silver. If no, if the metal which is not come in the group 1 or group 2 or it is not aluminum or zinc or silver, then how we will name the metal, designate the charge on the metal ion by putting the charge in the Roman numeral in parenthesis. And second thing, name the non-metal, use "ide" ending. If the compound is a binary, use the appropriate ending in the compound has a polyatomic ion. For an example, iron chloride. So here you can see this iron is, we have seen in previous general slide. You can see in this slide I have shown you the iron has 2+ and 3+, so it can be vary, the charges can be vary, right? So here iron, so according to this rule, second rule, so we have to put its charge in the parenthesis, and since we know the chloride has -1, chloride has -1 charge and there are 2 chloride ions, so it means to balance them there will be 2+ charge, right? So we have to write the iron in parenthesis in Roman numeral 2 and then chloride. So this is the way we have to write the name of ionic compound if the metal is not come from first A or second group, or it is not aluminum, zinc or silver. Another example is aurous tetrachloride. This is a gold, AU, which is called aurous. So gold, and again chloride has -1 charge and there are 4 chloride, so it means there are -4, total charge is -4. To balance them we need to put 4 after gold, so gold and then in parenthesis 4 and then chloride. So this is the way we have to write the name of ionic compounds, and then we'll see the other naming of ions and acids in the next video.